Problem 3. Using one line, a rectangle can be split into two pieces. That's shown in figure 1. Using two lines, a rectangle can be split into 4 pieces. Using 10 lines, how many pieces can be split at most? So right now, let's try to make a table. Just like all the other times, let's try to make a table. So that's my middle line right here, and I'm gonna separate this. Okay. This top is the number of cuts. You can talk about lines, anything. And this is the number of pieces. And again, just like last time, I need to remember to highlight the two words at most. Okay, so we know with one line, the rectangle can be split at most into 2 pieces. With 2 lines, 4 pieces. What about 3 lines? Okay, we can think of this as trying to cross as many lines through it as possible with another line. So I can think of going like this, for example. Okay. I can think of going like this. Now how much pieces do I have? We can count 1, 2, 3, 4, 5, 6, 7. Now number 4, we're trying to get one more line in. We could go like that. And over here there's a small space just to make sure. So now the number of pieces is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. At here I can stop because I'm starting to see another pattern. 2 plus 2 equals 4. 4 plus 3 equals 7. 7 plus 4 equals 11. So just like last time, this was the pattern. It was plus 1, plus 2, plus 3, plus 4. So we're trying to find, well, what about 10? So again, we are going to make that pyramid thingy. So, okay. So we're doing, well, first we have 1. That's our very first term, and we start with 2. For our second one, we do 2 plus 2. For our third one, we are doing 2 plus 2 plus 3. So what about our 10th one? Well, there's always this 2 in the front that doesn't go accordingly to the whole thing. Okay, now we're trying to find the equation for number 10. So the problem is we have this 2 sticking out of nowhere right here. So how can we represent that? Well, let's try to go back one. So for the 0th term, we have number 1 right here because 1 plus 1 would equal 2. So we can now think of this as 1 plus 2 all the way added up to 3 and 3, 2 and 2, so all the way added up to 10. So that's how this is going to work. Now I'm going to just calculate. Alright, so we leave that 1 aside, that's a bit extra, and we start pairing things up. So 1 with 10, 2 with 8, and so on like that. So the sum of each pair would be 11. And now we have to find the total number of pairs and multiply them together. The total number of pairs would be 10 divided by 2 because there are 2 numbers in each pair, which equals 5. So we times that with 5, and this equals 55. 55 plus 1 equals 56. So at most, using 10 lines, there can be 56 pieces. The key point of this problem is, after making this pyramid, we're not just going to think about what's given to us. Now we're thinking abstractly like mathematicians. We're starting to think, well, what about the 0th one? Because this 2 right here is very, very hard to work with. So actually, if I split that apart, I could get 1 plus 1 all the way to 10, and starting with 1 is much easier. So, I could have written this as 1 plus 1, this as 1 plus 1 plus 2, this as 1 plus 1 plus 2 plus 3. So the 1 just makes it easier. We can always take that out, or, this term right here is 0, the 0th term. Well, that doesn't make sense. This was the number of cuts. Well, that makes sense, because if there's no cuts, there's 0 number of cuts, then the whole thing is just one whole piece. That makes sense. And sometimes if we just add a term like that, or go back one more term, or add one more term to what we have, it actually makes everything much easier. So thank you for watching this video, and see you in the next